This next section is on buffers. Now there's lots of really cool buffers that happen either in nature, in your body, etc. So I really suggest finding a really neat example that speaks to you and then just use that to teach yourself a little bit about buffers and how they are occurring in real life. But just to kind of give you a recap of what is buffers, buffers are anything that can resist a change in pH. And so the way they do this is they always contain two components. One component is a weak acid and one is the salt of that weak acid, also called the conjugate base. And the idea is that you have a weak acid whose job it is to react with basic additions and a weak base whose job it is to attach with acidic additions. So if you use this as an example where you've got your acetate, which is your base portion, and then you have your acetic acid here. And so what happens is whenever an acid is added, you have that acetate that's ready to pick up an extra hydrogen and therefore prevents the change in pH even when a strong acid is added. Simultaneously, it can work like this, where if you have your acetate ion and you add in a hydroxide, then hydroxide grabs one of the hydrogens on the acetate and thus turns it into water. And so what happens is even though you add a strong acid or you add a strong base, there's enough of the basic components or the acidic components so that your pH doesn't really change. And this is really important because a lot of physiological conditions or things that happen in nature cannot happen if you change the pH even slightly. If you change the pH within our body by just 1 pH unit, you would die. It obviously depends on what aspect of our body we're talking about, but huge change have drastic consequences. So here is another example of it, of where you've got hydrochloric acid, you're adding in hydrochloric to a beaker, the hydrogen reacts with your acetate, your chlorine reacts with the sodium, thus giving you acetic acid and salt. And so neither of which is going to drastically change the pH of the solution. So this is the concept I'm wanting you to make sure you really understand from this section, is that most buffer solutions do contain two dissolved components. One is a weak base component, and its job is to neutralize incoming acid. The other component is a weak acid component, and its job is to neutralize any incoming base. Working together, those two components then can keep the pH from changing drastically. So kind of to recap, when an acid loses a proton, it becomes a conjugate base, and that conjugate base can react with other acids, and a buffer must be composed of a weak acid and its conjugate base, and so those things really work hand in hand together. A buffer resists changes in pH, and then strong acids and strong bases don't make good buffers because they completely dissociate in solution, and therefore you wouldn't have both components, a strong base and a strong acid, present for reacting whenever you added an extra acid or extra base. But with that, you are all finished with your homework for Chapter 7. This exam number 4 only covers Chapter 7. It doesn't cover 2 chapters, it just covers 1. So because of that, we have 2 writing assignments that you are going to be required to complete this unit, both of which are on The Disappearing Spoon. This is one of my favorite fun books to read about chemistry. It really does a fantastic job of storytelling about the periodic table. So I hope by this point in this semester you have enough information to really appreciate and understand what's happening in this book, but it's written for a non-scientific audience. So it's a really fun, interesting book.